Hey guys, today's lesson we are going to look at linear models. And basically these next couple of lessons should be review. There is a little starter activity that just talks about different types of graphs. I don't know what figure 13.1 is, but if we look at this problem, for each situation, think about how you would expect the given quantity to vary with time and sketch a graph to illustrate this. You do not need to include any numerical data. Basically just talking about what type of graph that would be. Like the population of the earth has always been exponential. The height of a ball thrown vertically upwards, well, a ball thrown vertically upwards normally comes back down at some point like a parabola. The distance traveled by an object moving at a constant speed. If we're talking about a constant speed, this would be speed and this would be distance down here. It would just be a straight line. The temperature of a cup of coffee left on a kitchen table, the temperature would constantly decrease. All right. The cost of a phone call, back in the olden days when you got charged for long distance, the cost of the phone call was kind of linear, or it would be in pieces. It'd look something like this, depending on you paid a certain amount for long distance. And now there's so many different packages, so the cost of a phone call usually is a piecewise function, but that's kind of what we're talking about. Find a linear model that goes through the points 1, 3, and 5, 11. Give your answer in the form y equals mx plus c. And we talked about how y equals mx plus b. Depending on where you are in the world, your answers are in different forms. So the first thing we want to do here is find the slope, change in y over change in x, which is 8 over 4, which is 2. And then we can just use point slope form, y minus 3 equals 2 times x minus 1, using this point in point slope form, distribute, and then add 3 to both sides. So we end up with y equals 2x plus 1. Okay, that is a basic Algebra 1 problem. That's all we got going on there. All right, the second problem we're going to look at, a mobile phone contract has a monthly charge of $50 plus plus $1 for every 10 minutes of call time for the first 100 minutes, then $1 for every 20 minutes of call time thereafter. So this is a piecewise function, and that's what this is saying. Form a piecewise linear model for the monthly cost in terms of call time per minutes. All right, so we know that when t equals 0, you are getting charged $50 no matter what. And our next piece of information talks about to 100 minutes. And when t equals 100 minutes, our cost is $60 because we have $50 plus $1 for every 10 minutes. So to the first 100 minutes, all right? So we've got $60 there. The next thing we need to know is what happens after that amount of time. And so when we take, let's say t equals 200, for example, our cost would be the original $50 plus the 10 minutes times $1, all right, and then plus 5, because there are 5 groups of 20 to get to another 100, 20, 40, 60, 80, 100. So that would get us to the second 200, and that gives us $65. All right, because this is 20 plus 20 plus 20 plus 20 plus 20, and each one of those groups is $1, $1, $1, $1, $1. Okay, that's where that's coming from. All right, so the first thing we need to do is find the slope between our first 2 points. So we could do 60 minus 50 over 100 minus 0, and we get 0.1. All right, so if we put this in point slope form, c minus 50 equals 0.1 times t minus 0, which is just c equals 0.1t plus 50. So there's our cost equation for our first set of information. And then let's switch and look at this other ordered pair, 160 and 265, because our slope will change. All right, so we're going to get 65 minus 60 over 200 minus 100, and that's 0.05. So again, point slope form, c minus 60 equals 0.05 t minus 100. Simplify and distribute, c equals 0.05 t plus 55. So there's our second equation. So our piecewise function looks something like this. We would have 0.1 t plus 50. I'm going to erase this because it's in my way. 0.1 t plus 50 for any time t is in between 0 and 100. And then our other equation would be 0.05 t plus 55 for t is greater than 100. All right, that's how we broke up that information. The second part of our question asks, find the total monthly cost in a month when the total call time was 350 minutes. So all we're going to do is say t equals 350 minutes. So c would equal 0.05 times 350, because we're using this equation here, because t is greater than 100, and then plus 55 for a total of 72.5. So the cost for 350 minutes is $72.50. That's a dollar sign. All right. Straightforward, looking at pieces of information. We're going to talk about this. We're not even going to talk about this today. So something else you don't have to worry about. So there are going to be a couple of homework problems from these exercises right here. Not too many, but basically finding equations of lines and maybe finding the equation of a piecewise function. So spend some time looking at that and going over this example again if you need to, but that's about all we've got today.